All right, what we're going to do here is we are actually going to order these fractions and improper fractions and mixed numbers on a number line. So whenever we're giving something like this, the first thing we're going to need to do is we've got to make sure that we're at least dealing with fractions. This is going to be the easiest case scenario. So the first thing I want to do is I want to convert this one here into an improper fraction. So, knowing the shortcut method that we already have gone over, we can say that this is simply 1 times 2, which is 2, and then add in the numerator, which gives us a new fraction of 3 over 2. So this is the same thing as saying 1.5. We convert that into an improper fraction, saying 3 over 2. Okay, so now we've got all fractions that we're working with. Some are improper, some are proper fractions. Now what we have to do is we have to make sure that we have all the same denominator. We have to make our bottoms the same in order to compare them, because right now the bottoms are all different. So we have bottoms like denominators of 2, 4, 6, and 3. All right, so what we have to do is we have to determine the lowest common multiple of those numbers, of those particular numbers, in order to find out what we're going to convert them into. So let's start off with 2. If we were to set up a simple times table grid here, this would be a simple method of doing it. So we've got obviously times 1 right here, and so anything times 1 is going to be itself. And then what we have is we just basically can skip count. That's what a multiple is, or we just go through our multiples. Like 2 times 2 is 4, 6, 8. And over here, actually let's add in a couple more here, times 5 and times 6. Okay, so we got 5 is 10, and then we've got 12. Okay, and then we do the same thing with 3s. 3, 6, 9, 12, 15, 18. And then we do our 4s. 8, 12, 16, 20, 24. And then we do our 6s. 12, 18, 24, 30, 36. All right, so now we've got ourselves a little bit of a grid. We have to find a multiple that is common amongst all of these multiples. And in this case, we can see that the number 12 is a common multiple in each of those 4 digits. So 6 has a multiple of 12 here when you go by 2. 4 has one here when you multiply it by 3. 3 has one here when you multiply it by 4. And 2 has a multiple when you multiply it by 6. Okay, good. So now that we know that our LCM, our lowest common multiple, is in fact 12, what we can do is we can start by converting all of these so that the denominators are now the same. Okay, let's take a look at the first one. Well, we're going to have to multiply this one here by 6, because 6 times 2 is 12, and 6 times 1 is 12, so this now becomes 6 over 12. And this one here is going to have to multiply by 3, because 3 times 4 is 12, and this becomes 9 over 12. Okay, now we've got 5 over 6, and that means we have to multiply this one by 2, and this becomes 10 over 12. We've got 1/3. We have to multiply this by 4. This becomes 4 over 12. This we have to multiply by 2. This becomes 20 over 12. And we have to multiply this one by 6. And this gives us a total of 18 over 12. So now we can actually see which are the smallest and which are the greatest. So we're going to take a look at what they actually look like on a number line. All right, so the first thing we need to point out is that number lines go on forever, and they go on forever in both directions. But for this drill here, what we've done is we've just taken a segment of the number line, and as you can see, when we count by whole numbers, this would be 0, This would be whole number 1, this would be 2, okay, and it's going to go on and on and on for an infinite number. Okay, now when we're dealing with fractions, remember we're dealing with parts of a number. So what we're doing here is we're saying, okay, the common denominator here is 12. So that means that one whole will be broken into 12 parts. So in order to have a whole, so 1, you're going to have 12 parts of 12. So that means that this segment along here must be split evenly into 12 parts. And then what we're going to do is we're going to assign each of these to the part on the number line. So we've already started off and we can say, hey, 6/12, which is 1/2, is already been labeled right here, 6/12. Okay. Then if we move along further, we can see 9/12. Okay, so we're already at 6, so we just have to go 7, 8, 9, and this here is going to be 9/12. All right, now we've got 10/12. Well, we just go one more. 10/12. All right, now we've got 4/12. Okay, well, from 6, you can just go 5/12, 4/12. All right, we've done this one, this one, this one, and this one. And now we've got 20/12. Okay, well, you know what? That's beyond. That's a larger number than one whole. So what we have to do is we have to go beyond that. And what we've done here is halfway between 12 and 24, which would be 2, we've got 18. So we can start here and we can just count over 1, 2, and that gives us 20/12. And then our final one, which is right here, which is 18/12, has already been listed. So now if we compare these and we say, well, what does that look like when we're actually just using our original fractions and improper fractions? Let's take a look at that. Now, getting back to our number line, we can see here that 1/2 is really the same as saying 6/12. So this here is actually 1/2. And we can say 3/4, well, that's the same as saying 9/12. 3/4 is the same as saying 9/12. 5/6 is the same as saying 10/12. 1/3 is the same as saying 4/12. And 10/6 is the same as saying 20/12. And 1/2 is the same as saying 18/12.